Welcome to solverfy.
This is chapter 27, problem number 24. We are given a beam of protons, and this beam is entering a magnetic field that is initially perpendicular to the direction of the speed, and then after some time it exits the fields in a way that the direction of the velocity is perpendicular to the initial direction. So from here we can conclude that actually any proton within this beam has traveled a quarter of the circumference, right? This is the quarter. So 2 pi r being the circumference over 4. Let's call this the distance traveled, which is given to us in the problem. So isolate these. Pi r over 2 equals x. From here, we can actually write the radius as 2x over pi. Now going back to the force, the magnetic force acting on the proton, Q times V times B, V and B being initially perpendicular with respect to each other. I'm dropping the sign term here because it's going to be equal to 1. That equals to mv squared over r. Well, in this case, we have capital R, right? So these are going to cancel out. And if we also, well, we're asked to calculate the magnitude of B, so let's isolate that, mv over qr. Let's plug in for r in this equation. So it's going to be mv over q 2x over pi. Then we're going to have mv pi over 2x times q. If we plug in the values for the mass of the proton, we take 1.67 times 10 to the power negative 27 kilograms times the speed is given to us as 1.2 kilometers per second. So we have to do the conversion to meters per second 10 to the power, by multiplying it by 10 to the power 3 times the pi, 3.14, divided by 2 times the distance traveled. It's given to us as 1.18 centimeters. So we're converting that to meters as well. And we have the mass of a proton, 1.6 times 10 to the power negative 19. So when we plug everything in, we're going to get 1.67 times 10 to the power negative 3 teslas for the magnitude of the magnetic field.